Hi and welcome to Data Garden. Thank you for checking out my video. In today's tutorial we will be once again working with RStudio and GGPlot 2, and the goal is to create 3 different plots and then to arrange them in a single layout so that we can, for example, distribute online or print out as a paper format. So in order to perform this tutorial we will need to load 3 packages. So let's use the library command and load the package ggplot2 first, and once again library and command will be grid, and I will from now on use the command and enter to perform the commands instead of pressing run here. Now of course you have to use control enter if you're on a Windows machine. And the final one that we want to use is gridExtra. So there we have our 3 packages loaded that we need. And now, of course, we also still need some data to use. So use the command data, and I will once again use the iris data set that we have already used in the last tutorial. Now let's have a quick look at the data set in case you're not familiar with it. We have here 5 columns, the 5th of which is the species of the iris flowers. We have a total of 3 different species. And then we have here 4 numeric variables that have different measurements of the iris flowers. Now the first plot that I want to go into today is the box plot. So for the box plot it would of course make sense to use the species as our x variable or independent, and one of these as our y or dependent variable. In this case I'm going to use the sepal length first. So let's start with the command ggplot, and in the brackets we type data equals iris, comma, mapping equals AES, and in brackets x equals species, comma, y equals sepal dot length. And let's add to it with a plus, and I'm going to create a new line to make it a bit more easy to read, and I'm going to use geom boxplot, and don't forget the opening and closing bracket here even though we don't have anything in it. So press run, and there we have our first box plot with ggplot. It was quite easy, wasn't it? Now we can add some more things to this plot in order to add some information, and also, for example, to make this outlier a bit more visible, because you can barely even notice it when looking at the plot. So the first thing I want to show you with regard to this plot is the command notch within the boxplot command. Notch equals true. Default is false, of course, as you can see. And if we add notch equals true to it, then we have just added these little notches to the plots. And I really like those. I always add them to my box plots usually. And in case you don't know how to read those, it's basically like a confidence level or confidence interval. And in this case, because none of the notches for the plots are overlapping, we can say with I think 95% confidence that the median of the different groups is not the same for any of the groups. Now I've just said that we want to make the outlier a bit more visible, and we can do this by typing within the boxplot command, comma, outlier, like let's just type out, and then we already get a lot of options here. So let's start with outlier dot color, and let's say that we want it to be red, and we have to type this in quotation marks, and comma outlier dot size equals, let's say, 3, and press run, and there we have just made our outlier a lot more visible. Now you can also use, for example, comma outlier.shape, and then you can type a number here, and for example I think 3 will give you a cross instead of the dot, but I think the dot is actually the best option that we have, kind of, so I don't want to use this. Now there's one more thing though, and that is we can actually flip the coordinates for the plot, and I think for a box plot that actually makes quite a bit of sense. So we can do this by typing plus, and I will once again create a new line and use, no, not geom, but coord flip, like this, and opening bracket, closing bracket, and press run. And yeah, as you can see, we have just flipped the x-axis and y-axis, and I think it makes especially sense for the box plot, because we can, especially if we have more categories, it makes it a bit easier to arrange the plots in lines rather than columns, and you can fit a bit more information into the same size of the plot. Now, I've said earlier that we want to finally arrange 3 plots into one layout, and in order to be able to do this, we have to give a name to the plot and save it as an object. So let's just type here in front of the comment, let's call it plot 1, and then we use this assign method where we use the less than sign and the dash to assign the name plot 1 to our plot, and press run, and as you can see, it was just saved. Now GGPlot will save the plot as a list, and from now on, by the way, if we, let's say, clear this plot, yes, and then press run again, it will not display the plot automatically. If you want to display the plot automatically while also saving it as an object, you would have to put like one bracket here in the front and another one in the end around all of this, and then press run, and then it will also automatically generate the plot, and it will also save it as an object. That's a nice little trick that I always like to use. Now, in order to generate another plot very easily, just for this demonstration, I will actually copy and paste this whole command, and I will just change the name of the plot to plot 2, and I will change the y variable to sepal width in this case. So let's run this one, and as you can see, we have just created a new plot, plot 2, and we can also see it here. Now that was very easy to do, but for the final plot I actually want to go into a different type of plot now, and that's the histogram. So I will once again be using a column from the iris dataset for this. In this case, let's go with the petal length. So let's type GGPlot once again, and the data will be iris, and the mapping equals AES, and in this case we don't define any x or y, we just type the one variable that we want to have, in this case petal.width, and after this one we type a plus, of course, and we type geom histogram, and once again don't forget the brackets, and press run, and there we have it, a histogram of the petal width. Now, I think there are still a couple of problems with the standard histogram. For once, it's like, I think, a pretty unappealing looking plot, so we will definitely want to change something about the look of it. But I also think here we see that we have close to 30 observations in this one bin, and I think we can get a bit more out of it if we change the bin width of the plot. And that's also the first thing that we want to do. So within this geom histogram command, type bin width equals, and with this we have to be careful because the ideal bin width of course depends on the type of data that we feed the plot. And in this case you notice that the values go from 0 to 0, 0.0, to 2.5. So an ideal bin width would maybe be something like 0.1. I think 0.1 is actually what we have here already, so maybe try 0.05. Let's see if that works. And yeah, unfortunately it doesn't. So actually let's quickly change this and use Peter length as our variable, and then use the bin width of 0.1. And yeah, now we have a different plot. I think this one is a bit better suited for this example. So actually let's go one step back now and delete this bin width and show how it looks without that. As you can see, we have once again these big bars, and what's different here is that our x values go from 0 to about 7, and so now we have a bit more room to play with the bin width. So let's once again add the command bin width equals 0.1 and press run. And now we have a bit of a finer granularity in these bars that the histogram creates. Now there are two more things that I want to do with this, because right now it's just gray and dull, and we can actually change this with the commands color and fill within the histogram part of the plot. So let's type comma and define color equals, and I will type in quotation marks dark blue, and let's see how this one looks. And as you can see, we have just created these lines around the plot. Now, what I like about this is that it actually makes it a lot easier to see. For example, here we have actually two bars that have exactly the same number of observations within the bin. And without these lines from the color command, it would be maybe almost not noticeable that there are actually two bars. It could be 3 as well, or it could be 1 if we don't look carefully. Now we can also change the fill of the bars, and we can do this with the command comma fill equals, and I'm going to use light blue for this one. Press run. And there we have it. I think this one already looks a lot more friendly than the original plots that we've had. So of course, if we want to arrange all of these plots into one layout, then we also have to give a name to this one, and I'm going to call it plot 3, of course. And I'm once again going to create the brackets around it in order to have it run immediately after defining it. Now, the final thing we want to do in this tutorial is to create a layout out of all the 3 plots that we have just created. And I do not want them to be just like one after the other, but instead I want the 2 box plots that we have created in one row, one left and one right, and then the histogram, because it is more of a wider style of plot, I want to have in one row in itself, so below the 2 box plots, but filling the whole width of the page. So we can actually do this very easily with the gridExtra package with the command grid.arrange. But in order to be able to do this, we first have to define 2 new objects. The first one is a list object where we define all of the 3 plots. So let's just call the list plots, and yeah, define it as a list, and the content of the list will be plot 1, comma, plot 2, comma, plot 3. Now that was easy. And we will also have to create a matrix object where we define in which place of the final arrangement which part of the list will be. So let's create a new object called layout, and we define that as a matrix. Now I will create it using the rbind command. I think that's the easiest, but you could also potentially do like matrix command or cbind, whatever you prefer. So let's create rbind and create a first vector in it, and this one will contain the values 1, 2, which means that in the top left, or in the left part of the first row rather, there will be the first object of the list, and in the second spot of the row there will be the second object of the list. So after the first vector we type comma and we create a second vector, and this one will have 3, 3, which means that in the second line, because remember binding by rows, in the second line there will be plot 3 both left and right. So this will be the third object and this will also be the third object. So we can run this command and we have just created our little matrix, and we can now use this information in the gridArrange command. This one goes grid.arrange, and we first have to define the groups, which is basically the name for the objects that we want to put in the arrangement. And this one is called plots, which is the list that we have just created, and comma layout matrix like this equals layout, and let's run this one for a moment. And as you can see, we have already created a single layout with all the 3 plots, just as I wanted it to be, where these 2 are on the top and this one fills the whole width on the bottom. Now I think there are still 2 problems with this plot. The first one is that there's no title to it, and the second one is that, you know, this completely fills out the page, and if we were to print it or distribute it, we would probably want to have some type of border around it, that if we print it out, for example, it does not fill the page out completely. So let's close this preview again, and let's add a little bit to the gridArrange command. So we can type another comma, and we can actually add text to all the sides of the document. In this case we want a title, so we will use the command top equals, and then in quotation marks type whatever title you want. I will just type arrangement of plots. Okay, and after that we type another comma and we use the command VP, which stands for viewport, equals, and then we type viewport, and then in the brackets we type width equals, and I think 0.8 is a good number, comma height equals, and I think 0.9 is a good number for this one. So look carefully, command is VP equals viewport, and then in the brackets we define first the width and then comma and then the height, and that's it. So press run, and there we have it. And I think this already looks a lot better. We have added our title, it's also centered, and then we have the plots, and there's a nice bit of a border around that one. So let's press close, and we can of course export it. For this one I like to use the actual export function and save as PDF, and then we can create here, for example, a different paper size. I will use the A4 in portrait mode, and I will click here the checkbox for viewplot after saving, and save, and there we have it. Our 3 plots arranged on an A4 page that is ready to be printed out. So that's all I wanted to show you in this tutorial. I hope that you have found it helpful. If you have, then I would be very happy about a thumbs up. If you want to see more content of this type, then make sure to subscribe to the channel, because I have more content coming up very soon. Thanks for watching, and bye bye.